This year we are going to learn an application of matrices and determinants, the very first chapter. We are going to study how to find the rank of a matrix. What is a rank of a matrix? How to find the rank of a matrix using elementary transformation. So let us know what is the rank of a matrix. The rank of a matrix A is the order of the largest non-zero minor of A, and it is denoted by rank of A. The row of A is nothing. We read it as rank of A. Rank of A is always greater than or equal to 0. The rank of a matrix of order m by n, then if the matrix is of order n by n, then the rank of A is less than or equal to the minor matrix Mn. The rank of a zero matrix is always 0. The rank of a non-singular matrix of order n by n is n. Non-singular matrix whose determinant value is not equal to 0. So if 3 by 3 matrix is not equal to 0, then the rank of the matrix is 3. If it is of order n by n, then the rank is n. We find the rank of the matrix using elementary transformation. What is elementary transformation? In the matrix, if we interchange any two row or column, that is, if Ri is moved to Rj and Rj is moved to Ri, or the column Ci is moved to Cj or Cj is moved to Ci. The multiplication of each element of a row or column by any non-zero scalar C, K. Ri is the rth row can be written as K into Ri. Same way, the ith column can be written as K into Ci. So addition of any two column or row is also possible. Addition of elements of any two rows or columns. The same scalar multiples corresponding to the elements of any other row or column. Then Ri is equal to Ri plus K Rj. Ci is equal to Ci plus K Cj. Now these are all the definitions of elementary transformation and rank of a matrix. We also see what is equivalent matrices. Now equivalent matrices, two matrices A and B are said to be equivalent if one is obtained from the other by applying any finite number of elementary transformation. Now elementary transformations is nothing but we transfer the rows and then rows of transferring of column is known as the elementary transformation. Now the next is echelon form. The matrix of order A of order m by n, a matrix A of order m by n is said to be in echelon form if every row of A which has all its entry 0 occurs below every row which has a non-zero entry. Say A11, A12, A13. See below that B21, B23, then here C33. See the zero should be off in triangular form. So bringing a given matrix 3 by 3 matrix in this form is known as echelon form, writing it like this. So the number of zeros before the first non-zero element in every row is less than the number of such rows in the next row. See here 1 0 and here there are 2 zeros. Then suppose we have another column, then it will be 0 0 0, then C4 4, something of that sort. So it should be of triangular form. Now in the exercise on point 1, the first question, find the rank of a matrix 5, 6, 7, 8. So this is of order 2 by 2. So you assume that A is equal to matrix 5, 6, 7, 8. Now we have to prove that this is a non-singular matrix. So find determinant A value. So determinant A is equal to determinant 5, 6, 7, 8. So this is equal to 40 minus 42. This is equal to minus 2, not equal to 0. Therefore, A is non-singular. So, therefore, the greatest minor of A is of order 2. Therefore, rank of A is equal to Now in the second question you assume let A is equal to matrix 1, 4, 2, 8. Now we are going to find out the determinant value of it. So determinant A is equal to determinant 1, 4, 2, 8. So this is equal to 8 minus 8 equal to 0. So determinant A is equal to 0 implies it is non-singular. Therefore, we will have to check up minor of order 1 as the minor of order 2 by 2 is equal to 0. We are going to find out the minor of order 1 by 1. So here every element is a non-zero element. It's not equal to 0. Therefore, rank of A is equal to 1. So first we should check up whether 2 by 2 minor is not equal to 0. If it is not equal to 0, then the rank of that 2 by 2 matrix is going to be 2. If the minor of 2 by 2 matrix, the determinant value of that is equal to 0, the minor of the highest order 2 by 2 is equal to 0. Therefore, the minor of order 1 by 1, if every element of A is 0, then it is 0. Even if you have one element, non-zero element of A, then the order will be of equal to 1. So if the minor of order 1 is not equal to 0, then the rank of A will be equal to 1. The fourth question in this exercise is 3 by 3 matrix. So let us assume the given matrix as A is equal to 2, minus 1, 1, 3, 1, minus 5, 1, 1 and 1. This is of order 3 by 3. Therefore, the rank of A should be less than or equal to 3 since the minimum minor of order 3 by 3 is 3. So, to find the rank, let us use elementary transformation in this question. So, after elementary transformation, therefore, making elementary transformation, then we will not be writing A is equal to, then we will be writing A is equivalent to. See, we can take this R3 to R1 and R1 to R3. So, first row will be 1, 1, 1, 3, 1 minus 5, 2, 1 minus 2 minus 1, 1. See, we make this transfer R1 to R3 and R3 to R1 in order to make our calculations easier. We are trying to make the first column, first element to be 1. Then this will be the next thing to rewrite it in echelon form. We are supposed to make the second row first element to be 0. So for that, this is equal to, rewrite the first row as it is 1, 1, 1. Now your R2 can be written as R2 minus 3R1 or 3R1 minus R2. So you 3R1, this R1 should be multiplied by 3. So here it is 3, 3, 3. So 3 minus 3 gives you 0. 3 minus 1 gives you 2. 3 minus 5 will become 8. See, the first row is multiplied by 3 to get 3R1. So 3R1 minus R2. So 3 minus 3, 3 minus 1, 3 minus of minus 5, so it is 8. Next we are supposed to make the first element of the third row to be 0. To make that, here R3 will be equal to, you multiply 2 into R1 minus R3. So you are going to multiply the first row by 2. If you are going to multiply the first row by 2, every element will be 1 into 2, 1 into 2, 1 into 2. So 2 minus 2 gives you 0. 2 minus of minus 1 gives you 3. Then 2 minus 1 gives you 1. Next our aim is to make this element to be 0. So equivalent to 1, 1, 1, 0, 2, 8. Our aim is to make this element 0. So you multiply R2. See 3R2 minus 2R3. Multiply the second row by 3, third row by 2, then subtract, you get this element cancel. So you multiply this by 3, you get 0, 3 2s are 6, 3 8s are 24. You multiply this row by 2, you get 0, 2 3s are 6, 2 1s are 2. So now you subtract 0 minus 0 gives you 0, 6 minus 6 gives you 0, 24 minus 2 gives you 22. Now this is in echelon form. So this is in echelon form. If this is in echelon form, we have to check how many non-zero rows are there. See, every row has elements, numbers without 0. So there are 3 non-zero rows. As there are 3 non-zero rows, rank of the given matrix A must be equal to 8. The next question is A is equal to 1, minus 1, 2, minus 2, 4, minus 3, 4, 2, minus 2, 4, minus 4. Again, this matrix is of order 3 by 3. Therefore, the rank of A must be less than or equal to 3, as the minimum of order is 3 by 3 is 3. Minor of minimum 3 by 3 is 3. Therefore, using transforming this in transforming matrix A in echelon form. A is equivalent to, see that we do have first element 1, so no problem. You can write as it is 2 minus 2. Now, the second element, second row first element should be equal to 0. So you multiply the first row by 4 and then add it with R2. So 4R1 plus R2. This is your second row. Your second row R2 is equal to 4R1 plus R2. So if you are going to multiply this by 4, minus 1 into 4 gives you minus 4. Minus 4 into 2 gives you 8. 4 into minus 2 gives you minus 8. Now adding this, plus 4 minus 4 gives you 0. 8 minus 3 gives you 5. Minus 8 plus 4 gives you minus 4. Next, your aim is to make this place a 0. So if this place a 0, what would you do? You are supposed to get 2 here. Then if you subtract, the term gets cancelled. So multiply the first row by 2. So your R3 is equal to, how are you going to get your R3? Multiplying 2R1 minus R2. See, if you multiply this by 2, you get minus 2. Get here 4, you get here minus 2. Multiplying by 2, 2 2s are 4. Now subtracting 2R1 minus R2. Subtract this, minus 2 minus 2, 0. 4 minus 4 is also 0. Minus 4 minus 4 is also 0. Now this is in echelon form. Okay. So this is in echelon form. But how many non-zero rows are there? See, this last row is completely 0. So there are only 2 non-zero rows. Therefore, but there are 1, only two non-zero rows. Only two non-zero rows. Therefore, rank of A is equal to. Follow. So, as there are only two non-zero rows, our rank of this question is equal to. So, the next question is A is equal to 1, 2, minus 1, 3, 2, 4, 1, minus 2, 3, 6, 3, minus 7. Here we have 3 rows and 4 columns. Therefore, the order of A is 3 by 4. So, maximum square matrix you are going to get is only 3 by 3. So, rank of A must be less than or equal to 3 since the minimum of the minus of order 3 by 3 is 3. Let us transform A to get in echelon form. How do we transform? The first element starts with 1, so no problem. 1, 2, minus 1, 3. Now we are supposed to make the first element of the second row to be 0. So multiply the first row by 2 and then subtract. So here R2 is going to be 2R1 minus R2. So 2R1 gives you 2, 4 minus 2, 6. 2 minus 2 gives you 0. 4 minus 4 gives you 0. Minus 2 minus 1 gives you minus 3. 6 minus 2 gives you 8. Now third row. Again we are supposed to make this element 0. We are supposed to make the first element of the third row to be 0. So your R3 is equal to, multiply the first row by 3. So 3R1 minus R3. So 3R1, you get this place as here 3, here 6, minus 3, 3 3s are 9. Now we are going to subtract. 3 minus 3 gives you 0. 6 minus 6 also gives you 0. Minus 3 minus 3 gives you minus 6. 9 plus 7 gives you 16. Now this is in echelon form. How many non-zero rows are there? There are 3 non-zero rows. So even though this is an echelon form, see, this second row is a multiple of the third row. Therefore, we can once again make an elementary transformation as 1. First row you leave as it is. Second row also as it is. Now third row you can multiply. R3 can be written as 2R2 minus R3. Then this place will be 0, 0, minus 6, minus 16. So subtract, plus 16. So this is 16. So you are going to get here, this is equal to 0, 0, minus 6, minus 6, 0, 16 minus 16, 0. So you are going to get the whole of last row to be 0. So how many non-zero rows? There are only 2 non-zero rows. There are, this is in echelon form, and there are only 2 non-zero rows. Therefore, rank of A is equal to. The second question, if A is equal to this, B is equal to given. You are asked to find out the rank of A, B and BA. So, if you wanted to find A, B, you are supposed to multiply the matrix A with the matrix B. matrix 1 minus 1 3 minus 2 4 minus 6 5 1 minus 1. We are supposed to multiply this row with this column. So this is going to be 1 minus 2 minus 5, then minus 1 plus 4 minus 1, then this with third column 3 minus 6 plus 1. Then second row with first column 2 plus 6 plus 20, then minus 2 minus 12 plus 4, then 6 plus 18 minus 4. Then third row with first column 3 plus 4 plus 15, then minus 3 minus 8 minus 3 minus 8 plus 3, then this with this 3 into 3 9 plus 12 minus 3. So this is equal to minus 7 plus 1 minus 6, 26 plus 2 28, 7 plus 15 22. This column minus 2 plus 4 gives you plus 2. Here minus 14 plus 4 gives you 10 minus 10. Plus 3 minus 3 gets cancelled, minus 8. Third one 4 minus 6 gives you minus 2. So here 2 20. Here 9 minus 3 gives you 6 18. Next, we are supposed to, this is your AB, we are supposed to find out the rank of AB. So now to find out the rank of AB, as this AB is of order 3 by 3, we get the rank of AB to be less than or equal to 3, since the minor of, since the name 3 by 3 is 3. We are going to make the elementary transformation to get this in echelon form. So we can take 2 common outside from this matrix. We can bring this column, the second column to the first place and first column to the second place. We get it here as 2 minus 10 8 minus 6 28 22 minus 2 20 18. What did I do? C1 to C2 to C1 and C1 to C2. Next, we are going to make this column cancel. So multiply this by 5 and add, you get the first element of the second row to be 0. So this will be equivalent to our aim is to make the first element of the second row. So first row you write as it is, and your R2 is going to be 5R1 plus R2. So 5R1, 5 into 2 gives you 10. 5 into 6 gives you minus 30. 5 into 2 gives you minus 10. So you add these two, plus 10 minus 10 gives you 0. Minus 30 plus 28 gives you minus 2. Minus 10 plus 20 gives you plus 10. Now, our aim is to make the first element of the third row to be 0. So to make the first element of the third row to be 0, multiply the first row by 4. If you are going to multiply by 4, you are going to get this place to be 8, this place to be minus 24, and this place to be minus 8. So what are you doing here? R3 is equal to 4R1 minus R3. So 8 minus 8 gives you 0. Minus 24 minus 22 gives you minus 66. Then minus 8 minus 18 is going to be minus 26. Next our aim is to make this place 0. So to make this place 0, we need to multiply the second equation by 33. Then we get 66. So this is equivalent to 2 minus 6 minus 2, 0 minus 2, 10. Now here R3 is equal to 33 R2 minus R3. So multiply 33, you get 66 minus 66. 33 you get 330. So this is, you are going to get 0, 0. 330 minus 26 is going to be, minus will become plus, so 356. So there are 3 rows, non-zero rows. So this is in echelon form. There are 3 non-zero rows. Therefore, rank of AB is equal to 2. Now we are supposed to find rank of B. We are supposed to multiply B into A. So BA is equal to, we are going to multiply B first. 1 minus 1, 3, minus 2, 4, minus 6, 5, 1, minus 1 into A value 1, 1, minus 1, 2, minus 3, 4, and 3, minus 2, 3. So BA is equal to, now this first row into first column, it's going to be 1 minus 2 plus 9, then 1 plus 3 minus 6, then minus 1 minus 4 plus 9. Then second row with first column, minus 2 plus 8 minus 18, minus 2 plus 8 minus 18, then minus 2 minus 12 plus 12. So the second row with this, minus 2 minus 12, then plus 12. Then third, for second column, second row with the third column. Second row with the third column gives you 2 plus 16 minus 18. Then this third row with this first column is going to be 5 plus 2 minus 3. Then 5 minus 3 minus plus 2. Then third row into third column, minus 5 plus 4 minus 3. Now simplifying this is going to be 10 minus 2 is going to be 8. Here minus 10 minus 2 minus 12. 7 minus 3 is going to be 4. Here plus 4 minus 6 minus 2. Plus 12 minus 2 gets cancelled, minus 2. Here we are going to get 2 plus 2, 4. Here 5 minus 9, 9 plus 9 minus 5, 4. Then yes, 16 minus 18 gives you 8 plus 18 minus 18 0. Then minus 5 minus 3 minus 7 plus 4. It is going to be minus 1. Minus 8 plus 4 going to be minus 4. This is your BA. So this is of order 3 by 3. Therefore, rank of BA must be equal to less than or equal to 3. Again, applying, transforming BA to echelon form. Echelon form. BA is equivalent to, again you can bring this minus 2 minus 2 4, 8 12 4, 4 0 minus 4. You have made C2 C1 to C2 and C2 to C1. This is equivalent to minus 2 8 4. See, you can add these two rows. You can subtract the C2 is equal, R2 is equal to R1 minus R2. If you subtract second row from the first row, minus 2 minus of minus 2 gives you 0. 8 plus 12 gives you 20. 4 minus 0 going to give you 4. Then multiply third row. R3 is equal to, you can multiply 2R1 plus R3. Multiply the R1 by 2, you get here minus 4. You get here a 16, you get here 8. So 4 plus minus 4 gives you 0. 4 plus 16 gives you 20. Minus 4 plus 8 gives you plus 4. Therefore, this is equivalent to, now you can subtract, write the first row as it is, second row as it is, third row R3 is equal to R3 minus R2 minus R3. Subtract, you are going to get 0, 0, 0. Now this is in echelon form. So this is in echelon form. Number of non-zero rows equal to 2. Therefore, rank of BA is equal to 2. The next question, if A is equal to 1 minus 1, 2 minus 3, 4, 3 minus 2, 3, and B is equal to the given matrix, then find the rank of AB and BA. Given A is equal to 1, 1 minus 1, 2 minus 3, 4, 3 minus 2, 3, and B is equal to 1 minus 2, 3, 2, 4 minus 6, 5, 1 minus 1. So the first of all we should find out what is AB, then find the rank of AB, find BA, and then find the rank of BA. So to find AB, so AB matrix is equal to 1, 1 minus 1, 2 minus 3, 4, 3 minus 2, 3 multiplied by 1 minus 2, 3, 2, 4 minus 6, 5, 1 minus 1. So we need to multiply this first row with this column. So this is equal to 1 into 1, 1. 1 into 2, 2. Minus 1 into 5, minus 5. Then this first row into second column. So this is going to be minus 2. 1 into 4, 4. Minus 1 into 1, minus 1. Then this first row into third column. So 3 minus 6 plus 1. Similarly, the second row with this first column. 2 into 1, 2. Minus 3 into 2, minus 6. 4 into 5, 20. Second row into second column. Minus 4, minus 12, plus 4. Then second row into third column. 3 into 2, 6. 6 into 3, 18. 4 into minus 1, minus 4. Third row into the first column. So 3 into 1, 3. Minus 2 into 2, minus 4. 3 into 5 gives you 15. Same way, 3 into the second. Third row into second column. 3 into minus 2 gives you minus 6. Minus 2 into 4 gives you minus 8. Plus 3 into 1 gives you plus 3. Third row into the third column. 3 3s are 9. Plus 12. Plus minus 3. So 9 plus 12 minus 3. Now this first row is multiplied with this first column. 1 into 1, 1. 1 into minus 2, minus 2. Minus 1 into 5, minus 5. This first row into second column. 1 into minus 2, minus 2. 1 into 4 plus 4. Minus 1 into 1, minus 1. This first row into the third column. 3 into 1 plus 1 into minus 6 plus minus 1 into minus 1 plus 1. Similarly, the second row with the first column. 2 into 1 gives you 2. Minus 3 into minus 2 plus 6 plus 4 into plus 5, 20. Second row with the second column. My 2 into minus 2, minus 4, minus 3 into 4, minus 12, 4 into 1 gives you 4. Then second row with the third column. 2 into 3, 6, minus 3 into minus 6 plus 18, 4 into minus 1, minus 4. Then the third row with the first column. 3 into 1, 3, minus 2 into minus 2 plus 4. Then 3 into 5, 15. Then the third row with the second column. 3 into minus 2, minus 6, minus 2 into 4 gives you minus 8, plus 3 into 1 gives you 3. Then third row with the third column. 3 3s are 9, minus 2 into minus 6 plus 12, 3 into minus 1 gives you minus 3. So now this is equal to minus 7 plus 1, minus 6. Here 26 plus 2, 28. 15 plus 4, 19, 20, 22. Then second column, plus 4 minus 3 gives you 1. Plus 4 minus 4 gets cancelled, minus 12. Minus 5 minus 6 gives you minus 11. Then plus 4 minus 6 minus 2. Plus 14 plus 6, 20. 9 plus 9, 18. Now this is your AB matrix. So to find the rank of AB, we need to write this matrix in echelon form. So to write it in echelon form, so we are going to write AB matrix is equivalent to, we can change this column, second column to the first, minus 12, minus 11, minus 6, 28, 22, minus 2, 20, 18. So the first elementary transformation we made is C1 to C2 and C2 to C1. We have changed the column in order to make our calculation easier, so that if 1 is in the first place, our simplification is easier. So the next it is equivalent to, see, our aim is to make this place a 0. So multiply the first row. So first row is minus 6 minus 2. Now this row you multiply it by 12. So R1 in R2 is equal to 12 R1 plus R2. So if you multiply this by 12, here it will be 12, here it will be minus 72, then this will be minus 24. So 12 plus 12 gives you 0, minus 72 plus 28 gives you minus 4, 6 minus 2, minus 44, minus 44. Minus 24 plus 20 gives you minus 4. Now to make this 11 gets cancelled, we are supposed to multiply R3 is equal to 11 R1 plus R3. So multiply the first row by 11. Here we are going to get 11 minus 66 minus 22. Adding these two, plus 11 minus 11 gets cancelled, 0. For 66 minus 22 gives you minus 44. 22 minus plus 18 gives you minus 4. Now your R2 and R3 are equal. So subtracting one from the other, this matrix will be equivalent to 1, 0, 0, 6 minus 2 minus 44 minus 4. Our R3 is going to be R2 minus R3. So this place will be equal to 0. Now this is an echelon form with two non-zero rows. This is an echelon form with two non-zero rows. Hence, rank of AB is equal to 2. Next, we are asked to find the rank of BA. So, to find rank of BA, first we need to multiply. Similarly, we need to multiply matrix B with matrix A. So, to find BA. So, to find BA is equal to, multiply the matrix, 1 minus 2, 3, minus 2, 4, minus 6, 5, 1, minus 1 with 1, 1, minus 1, 2, minus 3, 4, 3, minus 2, 3. So, you are going to multiply the row with column. So, this is equal to this row with this column. 1 minus 4 plus 9. This row with second column. 1 plus 6 minus 6. Then this row with this column. Minus 1 minus 8 plus 9. Now the second row with this first column. Minus 2 plus 8 minus 18. Second row with the second column, minus 2 minus 12 plus 12. Second row with third column, 2 plus 16 minus 18. Now the third row with the first column, it is going to be 5 plus 2 minus 3. Then third row with the second column, 5 minus 3 plus 2. Third row with the first column, it is going to be minus 5 plus 4 minus 3. Therefore, this is equal to matrix 10 minus 4, 6 plus 6 minus 6 gets cancelled 1. Here minus 9 plus 10 gets cancelled 0. Then minus 10 minus 2 minus 12. Here minus 12 plus 12 gets cancelled minus 2. Here you get plus 18 minus 18 gets cancelled 0. Third row, 7 minus 3 gives you 4. 7 minus 3 gives you 4. Here minus 8 plus 4 gives you plus 4. Sorry, minus 8 plus 4 gives you minus 4. So this is equivalent to C1 to C2 and C2 to C1. So this is going to be 1 minus 2, 4, 6 minus 12, 4, 0, 0, minus 4. So this is equivalent to, now our aim is to make this place 0. So we are going to get 1, 6, 0. R2 is equal to 2R1 plus R2. So multiply the first row by 2, you are going to get 2, 12, 0. So adding these two is going to give you 0, 0, 0. Then to make this place a 0, R3 is equal to 4R1 minus R3. So in multiplying this by 4, we are going to get 4, 24, 0. So 4 minus 4 is going to be 0. 24 minus 4 is going to be 20 plus 4. Now we can rewrite this as equivalent to 160. Now we can change R2 to R3 and R3 to R2. So 0, 24, 0, 0, 0. Now this is an echelon form where the last row is 0. So here there are two non-zero rows. Hence the rank of BA is also equal to 2. This is an echelon form with two non-zero rows. Therefore, rank of BA is also equal to 2. Hence, rank of AB is equal to rank of BA is equal to. The given homogeneous equations are x plus y plus z is equal 2x plus 5y plus 7z is equal to 52 and 2x minus y minus z is equal to 0 and you are asked to solve by rank method. Since we are asked to solve this question by rank method, we are going to write this in the matrix form. So writing this in matrix form, this is going to be 1, 1, 1, 2, 5, 7, 2 minus 1 minus 2 minus 1 into x, y, z is equal to 9, 52, 0. Therefore, augment matrix AB is equal to 1, 1, 1, 9, 1, 1, 1, 9, 2, 5, 7, 52, 2, 5, 7, 52, 2 minus 1, minus 1, 0. Now we are going to use elementary transformation to bring this matrix in echelon form. Hence, this is equivalent to 1, 1, 1, 9. To write this in echelon form, our aim is to make the first element of the second row to be 0. Therefore, R2 is equal to R2R1. 2R1 minus R2. So 2R1 multiplying every row by 2, you get here 2, 2, 2, 18. So 2 minus 2 gives you 0. 2 minus 5 gives you minus 3. 2 minus 7 gives you minus 5. 18 minus 52 gives you 34. Oh, sorry, 44. So 18 minus 52 gives you minus 34. Now again, to make the first element of the third row to be 0, R3 is equal to 2R1 minus R3. So 2R1 is multiplied by 2. So 2 minus 2 gives you 0. 2 minus of minus 1 gives you plus 3. 2 minus of minus 1 gives you plus 3. 18 minus 0, 18. Now our aim is to make the second element of the third row to be 0. So this is equivalent to 1, 1, 1, 9, 0 minus 3 minus 5, 54, 34, then minus 34. Now to make this row cancel, we are going to write R3 is equal to R2 plus R3. So adding these two gives you 0, 0, minus 2, minus 16. Then writing again, writing in matrix equation form. This gives you 1, 1, 1, 0 minus 3 minus 5, 0, 0 minus 2 into x, y, z is equal to 9 minus 34 minus 16, which gives you x plus y plus z is equal to 9 minus 3y minus 5z is equal to 34 minus 34. Then minus 2z is equal to minus 16. Now this is your first equation, this is your second equation, this is your third equation. Now from the third equation we get z is equal to minus 16 divided by minus 2, 8. Substituting in the second equation, minus 3y minus 5 into 8 is equal to minus 34. So minus 3y minus 40 is equal to minus 34. Take this 40 to the other side. Minus 3y is equal to the minus 34 plus 40 gives you 6. Okay. Minus 34 plus 40, this is equal to 6. Therefore, y is equal to 6 by minus 3 gives you 2. Substituting, this is your y value. Y is equal to minus 2. Plus 6 minus 3 gives you minus 2. Therefore, y is equal to minus 2. Here we have found out z is equal to 8. Now substituting this z value and y value in equation 1, we get x plus minus 2 plus 8 is equal to 9. So x plus 6 is equal to 9. So x is equal to 9 minus 6 gives you 3. So x is equal to 3. Hence, the solution is x is equal to 3, y is equal to minus 2 and z is equal to 8. The next question is, show that the equation 5x plus 3y plus 7z is equal to 4, 3x plus 26y plus 2z is equal to 9, 7x plus 2y plus 10z is equal to 5 are consistent and solved by rank method. So, to prove that it is consistent, we need to write the given equation in the matrix form, reduce it to the echelon form, and then we are going to find out the rank of AB is equal to rank of A. Then we can say it is consistent. So the matrix equation of the matrix equation corresponding to the given system is 5, 3, 7, 3, 26, 2, 7, 2, 10 into x, y, z is equal to 4, the constant 4, here the constant is 9, there the constant is 5. Therefore, the argument matrix AB is equal to 5, 3, 7, 4, 3, 26, 2, 9, 7, 2, 10, 5. Now here we are supposed to write it in echelon form. So let us try to make this place 1, we can divide the whole R1 by 3. So R1 divided by 3 divided by 5 will give you 1, 3 by 5, 7 by 5, 4 by 5. Write the other set of equations as it is. 3, 26, 2, 9, 7, 2, 10, 5. Now next our aim is to make the first element of the second row to be 0. So this is equivalent to, this will be equivalent to 1, 3 by 5, 7 by 5, 4 by 5. So now R2 is equal to 3R1 minus R2. So 3R1 you are going to multiply by 3. This will be 3. This will be 9 by 5. This will be 21 by 5. This will be 12 by 5. So in this place 3 minus 3 will be equal to 0. 9 by 5 minus 26. So in your upper column you can subtract 9 by 5 minus 26, taking LCM as 5. This is going to be 9 minus 130. So this is equal to 121 divided by 5. So minus 121 divided by 5. Next we are supposed to multiply 7 by 5 minus 2. So 7 by 5 minus 2 is equal to, taking LCM 5, 7 minus 10. So this is going to be minus 3 by 5. Now again 12 by 5. 21 by, here you are going to get 9 by 5. This will be 21 by 5. Here this will be 12 by 5. So 21 by 5 minus 2. So this is equal to 21 minus 10 by 5. We are going to get here 11 by 5. The next column is 10 by 5. Sorry, 12 by 5. 12 by 5 minus 9. So 12 by 5 minus 9 is equal to 12 minus 45 divided by 5. So this will be equal to 33 by 5. Our aim next here, to make the first element of the third row to be 0, multiply the first equation by 7. So multiplying this by 7, this will give you 7. Here you get 7 into 3, 21 by 5. 7 into 7, you get here 49 by 5. So here you get 4 by 5 into 7. So 4 7s are 28 by 5. So here again you are going to get this place. So if you are going to multiply 7 minus 7 is going to be 0. So 21 by 5 minus 2. So 21 by 5 minus 2 will give you, taking LCM 10, this is going to be 5. 21 minus 10 is going to be 11 by 5. Then the next place you have 49 by 5 minus 10. So 49 by 5 minus 10 is going to be 50. So 1 by 5 minus 1 by 5. Then 28 by 5 minus 5. So 28 by 5 minus 5. So 28 minus 25 by 5. This is going to be 3 by 5. So next our aim is to make this place 0. So multiply this row by 11 and add these two. So this is equivalent to, the first row is 1, 3 by 5, 7 by 5, 4 by 5. Second row 0, minus 1, 21 by 5, 11 by 5, 33 by 5. So this is going to be here minus 33 by 5 plus 12 minus 45 minus 33 by 5. So here R3 is equal to R3 R2 minus 11 R3. So you multiply this entire row by 11, you are going to get here 121 by 5. Here you are going to get 11 by 5. Here you are going to get 33 by 5. So this place will be 0. This also will be 0. This also will be 0. This also will be 0. So this is an echelon form where there are only two non-zero rows. This is an echelon form. There are two non-zero rows. Therefore, rank of A is equal to rank of AB is equal to 2, which is less than n. Therefore, the system of equations are consistent. Because the ranks are equal, they are consistent, but there are many solutions. So now we are supposed to solve for x, y, z. So to solve, we are supposed to rewrite in matrix form. What do we get? 1, 3 by 5, 7 by 5, 0, minus 121 by 5, 11 by 5, 0, 0, 0 into x, y, z is equal to 4 by 5 minus 33 by 5, 0. This gives you x plus 3 by 5y plus 7 by 5z is equal to 4 by 5. So, rewriting, this can be taken LCM as 5. We can rewrite the equation as 5x plus 3y plus 7z is equal to 4. This is your first equation. Second equation, minus 121 by 5y plus 11 by 5z is equal to minus 33 by 5. Now taking LCM, you get minus 121y plus 11z is equal to minus 33. Now this is your second equation. The third equation is 0. There are only two equations. We need to solve for three variables. Hence, let z is equal to some t belonging to R, the set of real number. Therefore, we are going to get minus 121y plus 11t is equal to minus 33. So, minus 121y is equal to minus 33 minus 11t. So, this minus 11 can be taken outside. 3 plus t, 121y minus. So, minus gets cancelled. Y is equal to 3 plus t divided by 11. 11 you can cancel on either side. So, you get y is equal to 3 plus t divided by 11. Substitute the y value in the first equation. You can find out the value of x. substituting z is equal to t and y is equal to 3 plus t by 11 in 1, we get 5 plus 3 into 3 plus t divided by 11 plus t plus 7t is equal to 4. So 5x. Therefore 5x plus 9 plus 3t divided by 11 plus 7t is equal to 4. Taking LCM as 11, 55x plus 9 plus 3t plus 77t is equal to 4. So 55x plus 80t plus 9 is equal to 4 into 11, 44. So this is equal to 44. So 55x is equal to 44 minus 9 minus 80t. So this is going to be 35 minus 80t. 55x. So this 5 can be taken outside. 7 minus 16t equal to 55x. Therefore x is equal to 5 into 7 minus 16t divided by 55. This gets cancelled and gives you 11. This is equal to 7 minus 16t divided by 11. This is the value of x. Therefore the solution is x is equal to 7 minus 16t by 11. Y is equal to 3 plus t divided by 11. And z is equal to t, where t belongs to the set of real numbers. Hence, x is equal to 7 minus 16t divided by 11. Y is equal to 3 plus t divided by 11. And z is equal to t, where t belongs to the set of real numbers. This is the solution. So the given non-homogeneous equations are x plus y plus z is equal to 3, x plus 2y plus 3z is equal to 4, x plus 4y plus 9z is equal to 6. Writing in matrix form. Writing in matrix form, we get 1, 1, 1, 1, 2, 4, 1, 3, 9 into x, y, z is equal to 3, 4, 6. Now to solve this equation and say it has unique solution, we are going to write this in augment matrix form, and then using elementary transformation we are going to reduce the equations. Therefore, augment matrix AB is equal to 1, 1, 1, 3, 1, 2, 3, 4, 1, 4, 9, 6. Now this is equivalent to 1, 1, 1, 3. Now our aim is to make the first element of the second row 0. Therefore, R2 is equal to R1 minus R2. So subtract R1 minus R2. 1 minus 1 is 0. 1 minus 2 is minus 1. 1 minus 3 is minus 2. 3 minus 4 is minus 1. The same way, to make the first element of the third row to be 0, R3 is equal to R1 minus R3. So 1 minus 1 is equal to 0. 1 minus 4 is equal to minus 3. 1 minus 9 is equal to minus 8. 3 minus 6 is equal to minus 3. Next, our aim is to make the second element of the third row to be 0. So write the first two rows as it is. Now our third row is going to be, so we are supposed to write here R3. So here R3 is equal to 3R2 minus R3. So 3R2, this place will be 0, this place will be minus 3, here it will be minus 6, here this is going to be minus 3. So 0 minus 0, 0, minus 3 minus 3, 0, minus 6 minus of minus 8 will become plus 2, then minus 3 is going to be 0. Now, therefore, there are, this place is already 0 minus 1. So now this is in echelon form. So therefore, there are, this is in echelon form. There are how many non-zero rows? 3 non-zero rows. Therefore, rank of A is equal to rank of AB is equal to 3. Equal to n. Hence, therefore, the system has unique solution. Now, to find the solution, we need to rewrite this in the matrix form. That gives you 1, 1, 1, 0, minus 1, minus 2, 0, 0, 2 into x, y, z is equal to 3 minus 1, 0. X plus y plus z is equal to 3 minus y minus 2z is equal to minus 1 and z is equal to 0. So if z is equal to 0, minus y is equal to minus 1, therefore y is equal to 1. This is your first equation, this is your second equation, this is the third equation. This is from 2. Now from 1. X plus 1 plus 0 is equal to 3. So x is equal to 3 minus 1. This is equal to 2. Therefore, the solution is x is equal to 2, y is equal to 1 and z is equal to 2. For what values of the parameter lambda will the following equations fail to have unique solution? So fail to have unique solution, we need to prove that that these equations are inconsistent, so they will not have unique solution. So the given equations are 3x minus y plus lambda z is equal to 1. 2x plus y plus z is equal to 2. X plus 2y minus lambda z is equal to minus 1. Writing this equation in matrix form, 3 minus 1 lambda, 2, 1, 1, 1, 2 minus lambda into x, y, z is equal to 1, 2 minus 1. Writing this in augment matrix. Augment matrix AB is equal to 3 minus 1 lambda 1, 2 1 1 2 1 2 minus lambda minus 1. Now our aim is to write this equation in echelon form. Hence, changing R1 to R3 and R3 to R1, we get this is equivalent to determinant 1 matrix 1 2 minus lambda minus 1 2 1 1 2 3 minus 1 lambda 1. Here R1 is going to R3 and R3 is R1. Next our aim is to make this place a 0. So this is equivalent to 1 2 minus lambda minus 1. Now to make the first element 0, we can write here R2 as 2R1 minus R2. So multiply this row by 2, you get 2 4 2 lambda 2. So 2 minus 2 gives you 0, 4 minus 1 gives you 3, minus 2 lambda minus 1 gives you minus 2 lambda minus 1, then 2 minus 2 gives you 0. Next our aim is to make the first element of the third row to be 0. Therefore, R3 is equal to 3R1 minus R3. So multiplying this by 3, we get 3 6 minus 3 lambda minus 3. Now 3 minus 3 gives you 0. 6 minus of minus 1 will give you 7. Minus 3 lambda minus lambda gives you minus 4 lambda. Minus 3 minus 1 gives you minus 4. Next our aim is to make this second element of the third row to be 0. Hence, so this is equivalent to 1 minus 2 minus lambda minus 1. Now this element, this R2, we can multiply by 7. So R3 can be written as 7R2 minus 3R3. So multiplying this by 7. Multiplying this by 7, we get 0 minus 21, plus 21. This into 3 will give you, 7 gives you minus 14 lambda minus 14 minus 7. So 0 into 7 gives you 0. Here multiplying it by 3, we get 0, 21 minus 12 lambda minus 12. So subtracting this minus this, second row is 3 minus 2 lambda minus 1, 0. Now subtracting 0 minus 0, 0. 21 minus 21, 0. Minus 14 lambda minus 7 minus 12 lambda. So this will become plus. So minus 14 plus 12 gives you minus 2 lambda. 7 minus 7. So 0 minus 12 gives you plus 12. So now this is in echelon form. Now if we wanted to have this solution to be a unique solution, if it is not a unique solution, then this 2 lambda, if the solution is not unique, then rank of A should not be equal to rank of AB, which implies rank of A must be equal to 2 and rank of AB must be equal to 3. That is possible only when minus 2 lambda minus 7 should be equal to 0. So minus 2 lambda is equal to 7. Lambda is equal to minus 7 by 2. So for lambda is equal to minus 7 by 2, the equations will fail to have unique solution. The next question speaks, the price of 3 commodities is X, Y, Z are X, small y and small z respectively. Mr. Anand purchases 6 units of Z and sells 2 units of X and 3 units of Y. Mr. Amar purchases a unit of Y and sells 3 units of X and 2 units of Z. Mr. Amit purchases a unit of X and sells 3 units of Y and a unit of Z. In the process, they earn rupees 5,000, 2,000 and 5,500 respectively. Find the price per unit of 3 commodities by rank method. So here we are asked to find the price per unit. That means price of 1 unit we are asked to find. And there are 3 transactions. Mr. Anand is making a transaction, Mr. Amar is making a transaction and Mr. Amit is making a transaction. So we are going to get 3 equations. The first one, Mr. Anand is purchasing 6 units and selling 2 units of X and 3 units of Y. So when he purchases, he is giving his money. But when he is selling, he is getting back his money. So whenever there is a purchase, we use negative sign. And whenever there is a selling, we use positive sign. So now the transaction is there. This transaction is X, Y, Z and totally what is the earning. So now this transaction, the first transaction is of Anand. The first man is Mr. Anand. This Anand is purchasing 6 units of Z. So here he is purchasing 6 units of Z. So this will become plus 6. Purchasing, he is going to shell out money. So minus 6. And he is selling 2 units of X. So this is positive 2 units. And 3 units of Y. So the first equation we get is 2X plus 3Y minus 6. And he is earning 5,000 rupees. So this is equal to 5,000. This is our first equation. Next person is Mr. Amar. Amar is purchasing a unit. That means 1 unit of Y. Purchasing. So he is giving out money. So this will become minus 1. And selling 3 units of X and 2 units of Y. So this is 3 and this is 2. Third person is Mr. Amar. Mr. Amit. Now this Miss Amit is selling a unit of X. That means what? 1 unit of X. So here minus 1. And sells 3 units of Y and a unit of Z. So this is 3 and this is 1. So the second equation we get is 3X minus 1y plus 2z is equal to, is getting 2000 rupees. Then third equation, minus x plus 3y plus z, 1z is equal to 5500. So purchases is negative. Selling is positive. So we get these three equations. Now solving these three equations in rank method, we are supposed to find out the unit price. That x is the unit price of the first commodity and y is the unit price of the second one and z is the third one. So writing this in the matrix form, we get 2, 3, minus 1, 3, minus 1, 3, minus 6, 2 and 1 of x, y, z is equal to 5,500, 5,000, 2,000 and 5,500. Next we will be writing this in augment matrix to find out the rank. Therefore, matrix A, B, augment matrix AB is equal to 2, 3, minus 6, 5,000, 3, minus 1, 2, 2,000, minus 1, 3, 1, 5,500. Now we are going to make equivalent to augment matrix A, B is equivalent to, now R1 is equal to, now R1 is going to R3 and R3 to R1. So we get here minus 1, 3, 1, 5,500. 5,500. The second row is as it is 3, minus 1, 2, 2,000. Third row is going to be 2, 3, minus 6, 5,000. Next our aim is to make the first element of the second row to be 0. So 3R2 is equal to 3R1 plus R2. So 3R1 gives you minus 3 9 plus 9, 3, multiply this by 3, 0, 0, 15, 16. So adding these two gives you minus 3 plus 3 gives you 0, plus 9 minus 1 gives you plus 8, plus 3 plus 2 gives you plus 5. Now 16,500 plus 2,000 gives you 18,500. Next our aim is to make this place 0. So you multiply the first row by 2. So first row by 2 gives you minus 2, 6, 2, 11,000. So now adding these two here, R3 is equal to 2R1 plus R3. So this gives you minus and plus gets cancelled. So 9 minus 4, this is minus 4, this is 16,000. Next our aim is to make this place 0. So this is equivalent to minus 1, 3, 1, 5,500, 0, 8, 5, 18,500. Now you multiply this equation by 9, you get 0, 9 8s are 72, 9 5s are 45, multiply this by 9, 0, 0, 45, 472 plus 476, 7, 9 plus 7, 16. Then multiply this row by 8, you get 0, 8 9 72, 8 4 32, 8 0 0 0 128. So now we are supposed to subtract one from the other. So you get your R3 is equal to 8 9 R2 minus 8 R3. So this gets 0 minus 0 0, 72 minus 72 0, 45 minus 32 will give you 77. Then this minus this gives you 500, 6 minus 6 0, 5. So you get 150500. So this will be, this is in echelon form. Now this is in echelon form, so we are going to solve for x, y, z. So 0 minus 0, 0, 72 minus 72, 0. Then 45 minus 32, so minus of minus, so 77. So 166500 minus 12800 gives you 0 0 5 8 3. So then this is in echelon form. This is in echelon form. There are 3 non-zero rows. Therefore, rank of A is equal to rank of AB is equal to 3. So it has unique solution. So rewriting in equation form, we get, therefore, minus x plus 3y plus z is equal to 5,500. 8y plus 5z is equal to 18,500. 77z is equal to 38,500. So from this, z is equal to 38,500 divided by 77, it goes 5 times 500. Substituting it, z is equal to 500 in equation 1. This is the equation 1, this is the equation 2, this is your equation 3. So substituting in 2, from 2, we get 8y plus 5 into 500 is equal to 18,500. So 8y is equal to 18,500 minus 2,500. So this is equal to 0.0061. So 8y is equal to 16,000. So equal to 2,000. Now substituting the values of y and z in equation 1, we get, from 1 we get minus x plus 3 into 2,000 plus 500 is equal to 5,500. Minus x plus 6,000 plus 500 is equal to 5,500. Therefore, minus x is equal to 5,500 minus 6,500. Therefore, x is equal to 1000. Hence, 1 unit of x commodity is equal to 1000 rupees. 1 unit of y is 2000 and 1 unit of z is equal to 500 rupees. Therefore, the price per x is equal to rupees 1000, y is equal to rupees 2000 and z is equal to rupees 500. The last question of this exercise is, an amount of rupees 5,000 is to be deposited in 3 different bonds bearing 6%, 7% and 8% per year respectively. The total amount of income is rupees 358. If the income from the first 2 investment is rupees 70 more than the income from the third, then find the amount of investment in each bond by rank method. Let us assume the investment in 3 different bonds be X, Y and Z. Let rupees X, rupees Y and rupees Z be the amounts deposited in 6%, 7% and 8% bond. So the total investment is given to be 5,000 rupees. Hence we get the first equation as x plus y plus z is equal to 5,000. So the first deposit is, total deposit is 5,000. Therefore, x plus y plus z is equal to 5,000. Secondly, it is speaking about the rate of interest. We know that simple interest formula is what? PNR by 100. So the first principal is x, number of year is 1, rate percent is 6. Therefore, here we get 6x by 100 plus 7y by 100 plus 8z by 100. So this total interest is equal to 358. So taking LCM, we get 6x plus 7y plus 8z is equal to 35800. So this is your second equation and this is your first equation. Thirdly, they say from the first 2 investment is rupees more than the income from the third investment. So first 2 investment income is 6x by 100 plus 7y by 100. Now this is 70 rupees more. That means third investment plus 70 rupees will give you the sum of the 2 investment. So this is equal to 70 rupees plus third investment is 8z by 100. So now taking LCM again, 6x plus 7y is equal to 7,000 plus 8z. Bring the 8z this side, 6x plus 7y minus 8z is equal to 7,000. This is your third equation. Writing these three equations in matrix form, we will get first equation is 1, 1, 1. Second equation is 6, 7, 8. Third equation is 6, 7, minus 8 into x, y, z is equal to 5,000, 35,800. This is going to be 7,000. So this is of the form Ax is equal to B. Writing in augmented matrix. Therefore, AB matrix. Augment matrix AB is equal to 1, 1, 1, 5,000, 6, 7, 8, 3, 5, 8, 6, 7, minus 8, 7, 7. Now, to rewrite this in Eklund form, we need to make elementary transformation. So, this is equal to 1, 1, 1, 5,000. Second row, R2 can be written as 6R1 minus R2. So this is equal to, multiplying this by 6, 6, 6, 6, 30. So subtract 6 minus 6 gives you 0. 6 minus 7 gives you minus 1. 6 minus 8 gives you minus 2. This is minus 5,800. The next line, we are supposed to make this 6 cancel. So R3 can be written as 6R1 minus R3. So subtract 6 minus 6, 0. 6 minus 7, minus 1. 6 minus of minus 8. So it will become plus 14. Then 30,000 minus 7,000 will give you 23,000. Next, our aim is to make this element 0. So this is equivalent to 1, 1, 1, 5,000. 0 minus 1 minus 2 minus 5,800. Now we are going to make R3 is equal to R2 minus R3. Now this minus this gives you 0. 1 minus 1, 0. Minus 2 minus 14 minus 16. Minus 5,800 minus 23,000 will give you minus 28,800. So now rewriting this equation, now this is in Eklund form. This is in Eklund form. There are 3 non-zero rows. Therefore, rank of A is equal to rank of AB is equal to 3. So it has unique solution. Now we are going to solve for x, y, z. Rewriting this in the equation figure. Therefore, x plus y plus z is equal to 5,000 minus y minus 2z is equal to minus 5,800 minus 16z is equal to minus 28,800. Now from these three equations we are going to solve for x, y and z. So this gives you Z is equal to 70 divided by 16. So 4 fours are 16, 7 fours, 2 fours, 0, 0, 4 fours here, 1800. So Z is equal to 1800. Substitute in the second equation, we get minus y minus 2z is equal to minus 5800 minus y minus 2 into 1800 is equal to minus 5800 minus y plus 0, 0 minus 0, 0, 16, 3 is equal to minus 5800. So minus y is equal to minus 5800 plus 3600 will give you 0, 0, 2, 2. Therefore, y is equal to 2200. So from equation 1, we get x plus y plus z is equal to 5000, x plus 2200 plus 1800 is equal to 5000. So x plus 4000 is equal to 5000. Therefore x is equal to 5000 minus 4000 is equal to 1000. Hence, the investments are rupees 1000, rupees 2200 and rupees 1800 in 6%, 7% and 8% bonds.